Hey everybody, this is Larry. This is day 29. Look at all those checks of the Leetcode May Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's poem. Maximum product of word lengths. Yeah, hope everyone's doing well. The new contest, or one of the new contests, is in, at least for me, in about 40 minutes. So hopefully this is good practice. Didn't do so well in the earlier one, mostly because Q4 required what is it called, segment 3, which I am familiar with, but it's been a while, or yeah, I just didn't have yeah, I'm just not as familiar with it in a good way. But yeah, anyway, yeah, let's go. Given a string words from the maximum values of length I and j. Okay. Where the two words do not come. Okay. Yeah. Okay. So I mean, given that n is equal to a thousand squares should be fast enough. Of course, this being Leetcode and this is Python, this is a little tricky, right? And also because, okay, I said n squares fast enough, or at least 1,000 squares fast enough, but that means that you have to do the two words not sharing a common letter part in a very quick way. If you don't, then it'll be, like if you just do, I don't know, something that goes through each word every time, then and it's going to be too slow. So what you want to do is pre-process it such that you are able to do set intersection in a quick way. I think, to be honest, I think if I were to do it in a clean way, I would have something like this, right? So I have, let's say, okay, and it's equal. Let's do it then. Let's just write it out. What I mean, right? So I have sets is equal to, I'm gonna say this for the. So that basically we have a set for each word, and then we could pre-process it such that, because basically, let's actually ignore the pre-processing for now. We'll ignore this thing for now. Without pre-processing, let's say we have something like this, and then we have some like check whether words of I and words of J have common letters, right? And of course, this is going to be very expensive because it's going to be 1,000. Say you have to look through the word. If you have to look through the word, you're already kind of lost, and so so we have to do some pre-processing, right? Because this is 1,000, this is 1,000, even though you can maybe make it 1,000 over 2 or 1,000 square over 2 by doing just this one simple trick. Well, yeah. And then if this also takes 1,000 by looking at the word, you're already too slow. So basically, we can reduce this to 26, but it probably is still too slow because if you think about it, it's going to be 26 times 1,000 times 1,000, kind of over 2 for 1,000 choose 2. But and if you really do the math, it is still like 13 million or something like that, right? I'm just doing it off my head, but which, to be honest, in most languages probably fine. But in Leetcode is just very weird for Python. But this is a good thing anyway. So yeah, so if you do this, that'll be too slow. 26 being the number of characters, but and this is what we would have, right? So our pre-processing would look something like this. Let's just do it anyway. Where sets up I is equal to, let's just say, get set of words, right? Actually, I guess we can just do none times n and then just do it here. Also, words of I, not words, but yeah. So now, given a word and a set is what we want is just a set of all the characters we've seen, right? So for C in word, s dot add C, return s, and that's pretty much it. We're going to run it. Just to be clear, my expectation is that it doesn't fit, but basically we can do something like if sets of I and sets of J, meaning that if the intersection, if the length of this is equal to 0, meaning that they have no common letter, because this is just a set intersection. The set intersection have no common letter. Then we do we do the length. Okay, let's also just do the length real quick. So length is equal to and this one is easier to write. We help length of word sub I, right? So if the intersection, then that also have a best for answer. That's just the way that I write it. And then here, current is equal to length of set sub I. We already did this, right? Sorry. Length sub I times length sub j. And then if current is greater than best, best is equal to current. Yeah, so this will be correct unless I have some typo. But like I said, I don't expect. I don't know if this will pass. And some of this is Python, some of this is Leetcode, or a lot of it's Leetcode, to be honest, because 13 million should be fast enough to pass. But yeah, so we'll see. Let's give it a submit. I like I said, I don't know that I expect to pass, but let's see how long this takes, right? Actually it does pass. So I lied here. But yeah, so this looks good then. But what I was going to do is turn into bit mask, right? So now, people ask me what a bit mask is a lot, and I do a tutorial on it. And this time, I'm going to use this up as an opportunity to go over a little bit of what this is, right? So this is going to be fast enough, of course, but as you can see. But what we can do is change this, right? So instead of, so this is now gets a set of characters of word, right? So then now another way to write it, of course, is a Boolean array, right? So instead of a set, we can just do force times 26. And then now we can do something like S of C is equal to true. It doesn't really work because C, we have to convert this to, we have to do this. And then now you have to write this in a little bit different way. But that's basically the idea, right? We just convert it to a set to a list of 26 characters. And of course, there is you can think about this as a Boolean array, but another way to do it is actually just having a bit mask, right? And a bit mask is the same idea as this, except for now, instead of, if you think about this array, what does that look like, right? So that's going to be, initially, it's going to be force, dot, force, right? So 26 of these. I'm just going to abbreviate another way of writing this, just for visualization. It's going to be F, or something like that, right? 26 of them, just pretend there is. And then now, and of course, it's an easy understanding. The first one is A, the second one is B, C, D, E, F, G, right? So then now we just have to flip it. And what this does is that, let's say we see a letter C, we go to letter C, the third letter, and we flip it from F to T. And basically, that's all we're doing with bit mask, right? So now, what is a bit mask? Bit mask is just transforming this Boolean array into a bit array, right? So now instead of F, or force, you now have a bit or number that represents all the zeros, right? So now these are all Fs. And if we, let's say, convert it at a C, we just convert it to the third character from 0 to 1. And that's basically the idea that we're doing. So let's do that. So let's say S is equal to 0. And then here, instead, we do. Right? And if this looks awkward to you, it probably is, for the first time. But basically, this is just I left shifts by the number of characters. So basically, you're saying, let's say we already have S, and let's say this is S. What we're doing is we're now just getting a number that's shifted by some number of bits, and then so this is, let's say this is Yi. I'm shifting it to the right, so maybe that's a little bit confusing. But now we or equal it so that this basically sets it from here and then puts it here. It's basically what it does. And if it's already a 1, then it just does nothing. So that's basically the idea here. And here, the AND does the same thing, which is the intersection, right? So now you're given 2 of them, and if they contain a common letter, that means that the bitwise AND will have something that's not 0. The only way they have no common letters is if they equal to 0. So basically, if this is equal to 0, then we do this other magical thing. And that's basically the idea. Bitmask doesn't have to be tricky, but you just have to get used to converting what we did. A Boolean array of 26 characters to just bits of 26 characters, right? And this looks okay. Let's give it a submit and see if it's that much faster. I suspect that's how, yeah, that's probably what I did a year ago. I'm just curious because yeah, that's something that I would do a little bit. But yeah, that's pretty much it. Like I said, this is going to be n. This is going to be n, also n. So this is going to be n choose 2 because we don't. Yeah, it's going to be n choose 2, and this is still technically 26, but now you're doing all the numbers together, which is why it's faster. And as I always say, this is only a constant speed up. So yeah, I mean, it is what it is. And in most languages, this will only be fast if the sets are like up to 32 characters or maybe even 64 if you use a long. But yeah, otherwise, as you can see, this actually gets a little bit expensive, and even the OR gets expensive if you get too big. So definitely look out for that. Cool. That's all I have for this one. Let me know what you think. Stay good, stay healthy, to good mental health. I'll see you later and take care. Bye bye.